Okay, so here we go. Let's do another one. So in this example here, we've got this one. And so now notice that this is very similar to a geometric series. And the geometric series that we're going to use is, notice this is 2 to the n over 3 to the n plus 1. Well, for large n, this is going to behave very much like 2 to the nth divided by 3 to the n, which is going to be equal to what? 2/3 to the nth power. So we're going to compare it to this one. Now, this is a convergent geometric series. R is less than 1. So this is going to be a convergent p-series. So now let's take the ratio and see what we get. So limit as n approaches infinity, and we're going to take 2 to the nth plus 1 divided by 3 to the nth, all divided by 2/3 to the nth power. Okay, so now let's write this as a multiplication and see what we can do here. The limit as n approaches infinity, we're going to write this as 2 to the nth plus 1 over 3 to the nth power times, this would be, oops, nope, don't want to do that, 3 halves. Yeah, we'll take the reciprocal. So 3 halves to the nth power. Now, this is just going to be what? Well, let's distribute the n. So this is 3 to the n divided by 2 to the nth power. Well, this 3 to the nth is going to cancel with this 3 to the nth power. And so now this equals the limit as n approaches infinity of what? It's going to be 2 to the nth plus 1 over 2 to the nth. Okay, now, where is this heading? Well, as n gets really, really big, this is heading towards 1, right? Or no? Yes, I believe this is heading towards 1. Yeah. If you split this up, you can see it better. So again, notice that this is the controlling behavior, so this is going closer to 1. You've got a plus 1, but as this gets really big, this plus 1 is becoming less and less significant. So that's what tells me that this is going to 1. But you can see it even better if you split this up into 2 fractions and you split it up as 2 to the n over 2 to the n plus 1 over 2 to the nth power. Well, this is always 1. Right? And so the limit as n goes to infinity is 1, which is not equal to 0, right? Which means, since this is convergent, right? So again, since the series for n equals, well, I'll just write the series, it's implied. So since the series of 2/3 n converges, so does okay, so does this one also converges. And this is by the limit comparison test. That's it.